so let's look at some of these. It says, use a math drawing, explain why. Basically, we divide by 2 and 2, and it gives you an equivalent fraction. So if I have 6/8 and then divide the numerator and denominator by 2, I get 3/4, which is an equivalent fraction. So if we think of, say I use pattern blocks of some sort and say that this is an eighth and I'm going to have 6/1/8. So I'm going to go ahead and draw 6 iterations of an eighth. And then 3/4 is the same length, so that would be 3 iterations of a fourth. So there's 1/4, 1/4, 1/4. And that from a linear model, they're the same length. That would show that they're equivalent. But why do we divide by the 2? Well, each 1/4 uses the length of 2/1/8. So it takes 2 of these guys to equal the same length as in a fourth. So if I group these by 2, then that gives me the length of an 1/4. So if I divide the 6 units or the Cuisinart rods into sets of 2, they create 3 things, so of the same length. And again, if I draw in my little dash lines for kind of what's missing of the whole, so to speak. So if I divide the 6 by 2, I'm taking those 6/8 and I'm putting them in sets of 2 linearly, and I get 3 things. The 8 is your denominator, that's your unit, and our unit used to be 8. But we're saying, well, but we're switching units and it takes 2 of these units to make 1 of those units. So if I take my 8, which is what the little units, there would be 8 of them in a whole to make your unit. If I'm changing units and it takes 2 of them, then I'm going to divide that unit and be like, well, I don't need 8 of them anymore to make a whole. I only need 4 of them to make a whole. So dividing the numerator by 2 tells me how long the shape is in a different, like, Cuisinart block. So instead of being 6 long, it's 3 long because it takes 2 of them to equal each other. But the unit used to be, it took 8 of the little guys to make the length of a whole. But again, if there's 2 of these and 1 of these, if I divide by 2, that means then there would be 4 of the slightly bigger Cuisinart rod to make that whole. So that's kind of where that dividing 2 comes from. And we can talk about that in terms of money in class as well, because I think money is kind of something that a lot of people know. All right, let's look at 6. They want us to plot what? 0, 3/8, and 1/3, I believe, all on the same number line. All right. And they want your big ticks, whole numbers, to be a little bit bigger. So there's my number line. We're going to put 0 here on a big tick, and we do need to plot it. So again, I'm going to put a pointer on that. All right, common denominator, I'm going to scale by 3. So I get what? 9/12, and scale, what would that be? Times 8 times 8. So what? 8. I don't know why I said 12s. How about 24? Is that better? All right, so 8 times 3 is 24, 3 times 3 is 9, and then over here I get 8/24. So my units are going to be 24ths. Now, I don't really want to put 1 down here and cut 24 little tiny things. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. All right, and put my point. This is 8/24, which again reduces to what? Or simplify, sorry, is a better word, 1/3. And then again, I'm measuring the same distance here. So then 9/24, put a point there, is my what? 3/8. And again, if I wanted to get 1 on there, I might be able to fit it. Again, based on distance, I can't just mark. I gotta kind of be consistent. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I mean, it's kind of hard to get 1 on there. And you don't even really have to. It just says, whole numbers. So if you add that much of the graph, totally fine. All right, let's look at what's next? Number 8. So number 8, you're supposed to plot these guys. All right, and again, it's kind of interesting. Decimal fractions pronounce the same way. We would say like 0.3 is a lazy way, but 3/10 is how you pronounce this, which is the same way we pronounce 3/10. So you can't really tell the difference because this is a decimal fraction. It is a fraction. We just write it with a decimal instead. So again, I am going to do my number line similar to what's in the book. They said if it's a whole number to make it a little bigger tick, so I'm going to do that. Common denominator, so I can plot these guys on the same unit. Because remember, getting a common denominator is putting them in the same unit. So tenths, so again, I'm going to go 1, 2, and I'm measuring the same distance, so you got to be consistent. This is 0.3 or 3 tenths. So there's 3, 4, 5, 6 tenths would be there, which again is 3/5. This one wouldn't be hard to get 1 on it. Again, keep measuring the same distance. So what is it? 7 tenths, 8 tenths, 9 tenths, 10 tenths would be 1 if you want to put it on there. But again, they didn't say you had to. So, but they did say to put a big tick on your whole numbers, right? So if you put it, just put a big tick on it and then plot these guys. All right, so after that, all right, so 21 is one of the trickier ones. So let's look at 21. 21 is kind of a double number line where you have units on both sides. So on 21, it says that she has ran 3 halves miles. So here's my number line. And here's, let's see, what do we have? Here's 0. And she's ran 3 halves, and this is mile. And that happens to be, what is that? That happens to be 2/5 of her run. And again, 0, 0 has to be together. So we have our miles on bottom and we have our run on top. And it wants us to focus on what is her total run. So I don't want to figure out what 1 mile is. I want to figure out what her run is. So again, we're going to focus on this to begin with. 2/5 is 2 1/5. So I'm going to cut this so I can see there's 1/5 of a run, 2/5 of a run, and I could keep going. Now, the other thing I could do is go 2/5 and measure out 2/5 again to get 4/5, then cut it in half to get a 1/5 and tack on the 1/5. But the other way is to go 1/5, 2/5, 3/5, 4/5, 5/5. So either way doesn't matter to me. And that is 5/5 is her whole run, okay? So first of all, I build up to her whole run. Okay, now I got to figure out what happened to the bottom. So you can kind of ignore the top because you got to her whole run. But you look and you're like, wow, I cut that in half, right? So I took 3 halves, and I divided it either by 2 or multiply by the reciprocal a half. This guy is 3/4. This guy would be what? 6/4, which reduces, which is nice. This guy would be 9/4. So I go 3, 6, 9. This guy would be 12/4. And this guy would be 15/4. So you build up to her whole run by cutting into the unit fraction of a 1/5, building up to 5/5. But then however this gets cut, it has to be proportional. So if this is 3 halves and I cut in half, I do the math and I get 3/4. So 3/4, 6/4, 9/4, 12/4 there. So, and this is in miles. So the answer would be 5/4 miles. Or 4 goes in there, what? 3 times would be 12 and 3/4, and this would be miles. So 15/4 miles, or if you want to do it as a mixed number, 3 3/4 miles would be her whole run. All right, and then the last one here, we have 23. So in 23, we have Rachel, which she is 3 strips. And then we have Leah, which what is she? Is she 4 strips? Okay. And so if we look at these, it says, write a sentence in which you use a fraction to describe how the amount of books that Rachel has read compares with the amount of, okay. So if we look at Rachel, okay, so Rachel has read, comparing Rachel to Leah, she has 3 out of Leah. So she has read 3/4 as many books as Leah has. So if these represent the number of books, now it could be 10, 10, 10, 30 books for her, 10, 10, 10, 10, 40 books for her. Or it could be 2, 2, 2, 6 books for her, 2, 2, 2, 8 for her. That we don't know. Okay, but Rachel has read 3/4 of the number of books Leah has read. Okay, but if I turn it around, then if I'm comparing Leah to Rachel, I would say Leah has read, she's read more than her. She's read 4 parts to 3, so she has read 4/3 of the number of books that Rachel has read. All right, so it kind of depends on what your whole is, like how you're comparing. All right, so if I'm comparing Rachel to Leah, she's read 3/4 compared to her, but Leah has read 4/3 compared to Rachel. All right, hopefully that helps, and I will grade the rest of them. Take care. Bye-bye.